Hello everyone. In this video we will walk through an algorithm for in-place reversal of a singly linked list, and we will program the solution in Python. This problem pattern comes up often in interview questions. In order to efficiently solve this problem, you need a solid understanding of the linked list data structure, as well as important programming concept known as pointer manipulation. Once you master these, you're well equipped to tackle this problem and implement the solution. For this video, I will start by giving an overview of the problem. I will explain my thought process as I go through the solution and implement the algorithm in an incremental manner. This will help you develop an intuition on how to approach similar problems, in addition to being able to follow along. So let's jump right in. So here I have a presentation of a very simple linked list that has some characters stored as data, and it has 4 nodes. So let's take a quick moment to quickly recap what these nodes are. So we call this a node, and each node object has 2 variables associated with that object. One variable called the value, one variable called next. And the next variable, the value variable, stores the actual data that we're interested in this case characters. The next variable stores the address of the next node in the sequence. So in this case, the next variable contains the address, the memory address of this node over here. So now let's take a look at the code for this class. So this is the Python code for the class. The code will be available on GitHub, and the link is in the description. So the class has a initialization function that takes a value and it assigns that value to the value variable of that particular object. And similarly, it will have a next variable that is given the value of none by default. So once you create a link or a node, it's important to update the next variable of that node accordingly. And this is the actual code for the solution. We will get back to this later. So now let's go ahead and see if we can find a solution to this problem. And anytime you approach a problem, it's always a good idea to start with the most intuitive and naive solution, even though we know that that's not what we will settle on. It's important to start with that. So let's take that approach here. If we were to take the most intuitive approach, we can say, we can travel through this linked list once, and we can just quickly update the pointers to point at the correct thing based on where we are. So if we're here, we maybe have this one point to none, and etc. So let's go ahead and do that. Let's see what happens. In order to do that, we're gonna declare a variable. We call it car or current, and this variable will help us keep track of where we are in the linked list as we travel through it. So let's go ahead and write down the code for that over here. So we can say current.next equals none. Great. So that will achieve this for us, and this is something we have to do based on the problem statement. However, once we do this, we're overriding the variable next for this object. So it's no longer has the address of this node. It has none in it. And you can see how that is a problem, because now we lost the link to the rest of the linked list. So we have no way of continuing this approach. So it becomes quickly evident that we can't just pass over this and update the values on the fly. So what's the most intuitive way to tackle that problem? If the problem is that we we're losing track of this address of this node, then a simple solution to that is we just introduce a new variable. Let's call that next, to store that value for us before we override it. So we take this value and we store it in next. And of course we would have to do this before we override it, because once we override it, it's too late. So this line has to go before our previous line. And we can say next, our new variable equals current.next. So we're simply taking a copy of this before we override it with none. And continuing with that mentality, that naive mentality, another problem that we see here is that this is not scalable to the rest of the linked list. Here we have a static value, whereas this value can change based on where we are in the linked list. If we're here, of course, it's going to be none. If we are on the second link, we want it to be this node, the address of this node, because that's what this should point to. So you can quickly see that we need another variable here to keep track of what the previous node is, so that we don't always put none. So let's go ahead and introduce that variable right now. We can call that variable prev for previous. And when we first run this code, of course, it's going to be none. So we can initialize it to none to solve for that very first iteration. However, as we move through the linked list, it's going to change to reflect where we are in the linked list. So let's go ahead and make that change here. Let's utilize our new variable here. Great. So far we have these three variables to kind of help us achieve the goal here as we move through the linked list. So now these two lines pretty much do what we want, and if we could apply these two lines for any given node, we would be able to arrive at the solution. So now the next step is to scale this to thinking about incrementing these variables to iterate through the whole linked list. And perhaps the first thing that comes in mind is, since we started initially with this current value, it's tempting to say, well, let's update that first. Let's keep moving forward. But the problem with that approach is once we update this, we lose track of this node over here. We don't know where that is, right? So just like we need a pointer to keep track of this end of the linked list, we need a pointer for that. And we did create the previous the prev variable over here to keep track of that. So why don't we update that first? So let's do that. So we can say prev equals car. So we grab a copy of it. So now we have our prev variable pointing to this and not to none anymore. And now we can safely go ahead and move the current variable forward. And how do we move it forward? You have to be careful here, because we can't say car equals car.next, which is something we normally do and we're used to when we're working with linked lists. However, in this case, we've already updated that value and it's no longer pointing to the next node. But we did take a backup of it, luckily, over here. So we can say current equals next. And that would make it look like that. Perfect. So now we just found a way to not only update the next variable of this node to the correct value that we wanted to, but also safely do so and move to the next node, which is now our subject that we're going to process. So let's go ahead and run through these 4 lines one more time for our new variable. So next equals current.next. That means we update the next to point to current.next, which points to this one. So next is now pointing to that. And then current.next equals previous. So current.next is the variable inside of this object. So we are breaking that link and we are having it point to previous, which is this right here. Great. And now previous equals current. So this is where we're starting to move forward. We've updated the link here. We're gonna move to the next node. So previous is now pointing to that. And finally, we update the current to move forward. So current is now pointing to this. And we repeat the same 4 steps for this node, which would result in breaking of this link and the addition of this link. And it would also result in these pointers incrementing by 1. And if we continue this approach, of course, we will have our updated or modified linked list at the very end. And then the question becomes, we obviously need to put this in a loop. And let's say we go with a while loop, and of course there are other ways to do it, but how would we know when would be a stop? So let's think about that very last step. Once we're at the very last step, what would be the ideal case for us? We want our next value to stop here. We don't want it to go any further than that. So if our next value is here, then if you take this still shot of this picture over here and apply that to that last node, we would also have our current value there because these two point at the same thing. And we would have our previous value point to this one over there. And that's where we want to stop ideally. And to make that happen, we can simply use the current variable as our kind of signal to tell us if the current variable is none, then we're at the end and we're done with the loop. And then we just simply take that and put it inside the while loop. And the final question remains that what do we return at the very end? And here we can simply see that the previous value is pointing to exactly the head of the new linked list or the modified linked list. So we can just simply return that value, that variable. So now let's go ahead and look at the code. Again, this code will be available on GitHub. There will be a link in the description section below. So this is just a very basic error checking, just to make sure that we're not given a empty linked list with a head pointing to none. And here we're just doing some basic initialization, having our current variable point to head and our previous initialized to none, as we discussed earlier. Inside the while loop, we have our 4 lines that we derived from the exercise earlier. And here it's just the extra step of updating the head variable, but we could just simply return the previous variable like we did in the exercise earlier. This section of the code is just to derive the function, and it just creates a very basic linked list based on the class that I've created here, and it just passes that through the reverse function. And if you run this code, you will get this output, and you can see that the linked list was reversed. Feel free to download this code, and I look forward to getting suggestions for improvements. And please let me know if this video was helpful to you. Feel free to subscribe and suggest the programming problem for a future video. Thanks for watching, and happy coding.